everyone, welcome to the lecture Design and Analysis of Algorithms. Myself, Devananda Rao, working as Associate Professor in the Department of CSC, MLR Institute of Technology, Hyderabad. The overview of the presentation. The topics to be covered are: what is an algorithm, characteristics of an algorithm, different ways of representing an algorithm, distinguish between algorithm and program. So, what is an algorithm? First, we will see what is the formal definition of an algorithm. An algorithm is a finite sequence of unambiguous instructions for solving a problem, that is, to obtain the required output for a legitimate input in a finite amount of time. Here, finite sequence. Finite sequence means there are a finite number of steps in the algorithm. The algorithm should contain finite number of steps. The steps are also known as instructions should be unambiguous. Unambiguous means should be clear, precise. Should be clear and precise. What does it mean? Unambiguous. See, unambiguous means example, add 5 to a number. Here the instruction is clear. That means 5 is added to a number. 5 is added to a number. Then what is unambiguous instruction? Ambiguous instruction. Ambiguous instructions. Do the step, ambiguous instruction. Do the step quickly. Here quickly, the ambiguous is how quickly. See, the algorithm should contain unambiguous instructions. Instructions should be unambiguous like this. Add 5 to a number. 5 is added to a number. Here, do the step quickly is ambiguous. Ambiguous because here the question rises, how quickly? So that an algorithm is a finite sequence of unambiguous instructions for solving a problem to obtain the required output for a legitimate input in a finite amount of time. So we will see a simple real-time example to understand these unambiguous instructions. See, example, real-world example, make a tea. Make a tea. So, to make a tea, the instructions are, first we will see ambiguous instructions. Step 1. Take some water. Step 2. Heat it until it is hot. Heat it until it is hot. Put tea in it. Put tea in it. 4th. Add some milk and sugar as needed. Some sugar and milk as needed. Make tea quickly. Here the instructions, all instructions are ambiguous instructions. Take some water. How much of water? Here the measurement is not given. That is question, ambiguous question. Heat it until it is hot. Heat it, it is hot. How much temperature? Hot means how much temperature. Put tea in it. How much of tea leaves we should pour in it? That is another ambiguous question. Add some sugar and milk. How much of sugar and how much of milk? And make tea quickly. How much quickly means how much quickly. These are the ambiguous instructions. Now we'll see unambiguous instructions. Step 1. Take 200 ml of water in a kettle. Take 200 ml of water in a kettle. Second instruction. Heat the kettle until the water reaches 100 degrees C. Heat the water until it reaches 100 degrees C. Add 1 teaspoon of tea leaves. 1 teaspoon tea leaves to the water. Water means boiling water. Fourth instruction, allow it to boil for 3 minutes. For 3 minutes. Then add 50 ml of milk and 1 teaspoon of sugar. Last step, stir for 30 seconds and serve. These are the unambiguous instructions. Each and every instruction is clearly, precisely mentioned. There is no ambiguity. Algorithm can easily understand this. Take 200 ml of water in a kettle and heat the water until the water reaches to 100 degrees centigrade. Add 1 teaspoon of tea leaves to the water, that is already boiling water. Allow it to boil for 3 minutes. Add 50 ml of milk, 1 teaspoon of sugar, stir for 30 seconds and serve. These are the unambiguous instructions. Now you can understand this unambiguous instructions for solving a problem. That is to obtain the required output for a legitimate input for an amount of time, finite amount of time. See, what is legitimate input? Legitimate input. Legitimate input is valid input. Valid input. See, example, what is valid input? If there is instruction in the algorithm, add 2 numbers, so that the algorithm expects input as 2 numbers. For example, if you give 5 and 7 as inputs, the output should be 12. Otherwise, if you give one input as apple, other input as 10, second input is 10, so this is invalid input. The algorithm expecting 2 numbers. So this is the formal definition. So we'll see this formal definition step by step. An algorithm is a finite sequence of unambiguous instructions. Purpose to solve a problem. So any real world problem can be solved by writing algorithm. The purpose is to solve a problem. Goal. The goal of the algorithm is to obtain the required output for a legitimate input. And time constant. Any algorithm must terminate in a finite amount of time, because the algorithm should contain finite sequence of instructions. Next topic, characteristics of an algorithm. See, the algorithm having some characteristics: input, output, finiteness, effectiveness, and definiteness. We will discuss one by one. Input characteristics of an algorithm. It should take 0 or more inputs. Definiteness or unambiguous. Each step must be clear and precisely defined. There is no ambiguity. It should not open for multiple interpretations, different interpretations. The algorithm, if you write on any algorithm, the algorithm should be clearly, precisely, the statement should be clear and precisely defined. It should not open for different interpretation of the instruction. Effectiveness. Each step must be basic enough to be performed, ideally by a human with paper and pencil. So the problem is given, we need to write an algorithm step by step. Those steps can be solved by using pen and pencil. Output. It should produce one or more outputs. Finiteness. It must terminate after a finite number of steps. These are the 5 important characteristics of an algorithm. Then algorithm may be written in many ways. In English also we can write an algorithm in simple English language, natural language. Step 1. Here the algorithm is for adding two numbers, say A and B. Step 1 is start. Any algorithm begin and end with start and stop. So step 1 is start. Step 2, read two numbers, say A and B. Third step, compare A with B. Here two sub steps are there. If A is greater than B, then A is the largest. Otherwise, B is the largest. Step 4, display the largest number. Step 5, stop. These are the steps written in English language, so that any algorithm can be represented in English language. Second method, the algorithm can be represented by using pseudocode. Algorithm, name of the algorithm is largest of 2. Algorithm having name. Here, pseudocode can use programming constructs. Most of the programming constructs can be used in pseudocode, so that we can convert the pseudocode into any programming language easily. Step 1, start. Step 2, taking inputs A and B. Step 3, if A is greater than B, we are checking the condition. If A is greater than B, print largest number is A, else print largest number is B. Step 4, stop, end the algorithm. So most of the languages having programming constructs, those programming constructs can be used in the pseudocode. Third way, another representation is flowchart. By using flowchart also we can represent an algorithm. So here we can use different symbols to represent algorithm in flowchart. So start, the first is start step. After that, the processing symbol is taken to read the numbers A and B. Then the diamond shaped symbol is taken to check the condition, is A greater than B. If the condition is true, we can get, if the condition is S, satisfied, A is largest. Otherwise, the condition fails, B is largest. So based on the condition, we will get the result. So final step is end. So that any algorithm can be represented by using natural language, any language, by using pseudocode or using flowchart. Next, algorithm versus program. The distinguish between algorithm and program. An algorithm is a step-by-step procedure to solve a specific problem. What is program? Program is also a step-by-step procedure to solve a specific problem. Then, so what is the difference? Same, almost same. Algorithm and program statements are same. Algorithm is a step-by-step procedure to solve a specific problem. Program is also a step-by-step procedure to solve a specific problem. So what is the difference? We will see the difference. An algorithm is an abstract concept, whereas a program is a concrete implementation of the algorithm. Program is concrete implementation of the algorithm. Algorithm is an abstract concept. We will see what is this. See, this is an algorithm. See, this is the algorithm for factorial of n. Step 1, start. Initialize a variable result to 1. Here, result is a variable, initialize it to 1. Then third step, read the input number n. Then repeat the following steps until n becomes 0. So the sub statements are, each step multiply result by n. After that, decrement n by 1. So whenever n becomes 0, the loop will be, we can come out from the loop and go to fifth step, print the value of result. The factorial of a number n is stored in the result as a factorial, so that in fifth step we can print the value of result. Sixth step, stop. This is algorithm, step by step statements. But what is program? So to write program, we need some programming language like C. Without programming language, we cannot write program. So program is a concrete implementation of the algorithm. Algorithm is an abstract concept. Here in C language, the name of the function is fact. It is of type integer. The parameter is n. N is of type integer. We are going to calculate factorial of n. So in this, the result is initialized to 1 initial step. Then check the condition. While n is greater than 0, result is multiplied with n every step. Result is equal to result into n. Every step n is decremented by 1. Whenever n becomes becomes 0, we can come out from the loop and result and print the result or return the result. This is the program. This is one of the differences between algorithm and program. Next, second difference. An algorithm can be written in any language like English language. Any language, using any language, you can write an algorithm. While a program must be written using a programming language. Using programming language only, we can write the program like C, C++, Java, like that. This is the algorithm. This is implementation of an algorithm. Third difference. An algorithm is developed during the design phase and a program is developed during the development phase of software lifecycle. So after requirement analysis, during the design phase, algorithm is developed. During the design phase, algorithm is developed. In the software lifecycle model, during design phase, we can develop algorithm. During development phase, we can develop program. So program is concrete representation, concrete implementation of an algorithm. See, we'll see the differences step by step between algorithm and program. The first difference, algorithm is an abstract concept, program is a concrete implementation. Algorithm can be written in any language, program can be written using programming language. Algorithm developed during design phase, program can be developed during development phase. Fourth step, algorithm is independent of the hardware and operating system. To write algorithm, hardware is not required. Operating system is also not required. By using pen and paper, you can write algorithm. Coming to program, program depends on the hardware and operating system. So, program is written using any programming language. That language should be run on computer by using operating system and hardware. Without hardware and operating system, we cannot execute program. So, overview of the course. In this course, we are going to discuss about main two different things. One is tools for analysis, another is tools for design. Tools for analysis means we are going to analyze an algorithm by using two notations, asymptotic notations and recurrence relations. And tools for design, we are going to design an algorithm for different problems. For different problems, different strategy is used. Different tools are available. So, the one of the famous strategy tool for design algorithm is divide and conquer strategy. Then greedy method, dynamic programming, backtracking, and branch and bound tool.